High above us, on a clear night, you can spot a simple W-shaped pattern of stars known as Cassiopeiae. It's one of the easiest constellations to recognize. Right at its center is a bright star that for over 50 years kept astronomers guessing. That star is Gamma-Cassiopeiae, often called Gamma-Cas. At first glance, Gamma-Cas looks like just another bright star, but scientists quickly realized something about it wasn't normal. Its light didn't behave the way it should. Back in 1866, an Italian astronomer named Angelo Secchi noticed that the star's hydrogen signature appeared bright, not dark like in stars such as our Sun. That might sound like a small detail, but it completely changed how astronomers understood certain stars. Because of this discovery, Gamma-Cas became the first example of a new type of star called a B star. These are hot, massive stars that spin incredibly fast, so fast that they throw material off their surface. That material forms a glowing disk around the star, almost like a ring of gas floating in space. Over time, this disk can grow, shrink, and change, but Gamma-Cas had another secret. In the 1970s, astronomers detected something shocking. The star was producing very strong X-rays, far stronger than what stars like this are supposed to emit. This wasn't just a minor difference. The energy levels were extreme. The X-rays were coming from gas heated to around 150 million degrees Celsius. That's unbelievably hot, far hotter than most stellar surfaces. So the big question was, where was all this energy coming from? For decades, scientists argued over two main ideas. One group believed the answer was magnetic activity, something like powerful interactions between the star and its surrounding disk. The other group thought there might be something hidden nearby, a companion object pulling in material and releasing energy in the process. The problem was, no one could actually see this companion. Even with powerful space telescopes like XMM Newton and Chandra X-ray Observatory, the evidence wasn't clear enough to settle the debate. The mystery of Gamma-Cas remained unsolved for decades. Then came a new mission, XRISM. This advanced X-ray observatory gave scientists a much more detailed look at what was happening around the star. And finally, things started to make sense. The data revealed that Gamma-Cas is not alone. It has a hidden companion, a white dwarf. A white dwarf is what remains after a star like our Sun dies. It's incredibly dense. Imagine packing the mass of the Sun into something about the size of Earth. This white dwarf is quietly orbiting Gamma-Cas, and more importantly, it's pulling in material from the star's surrounding disk. That material doesn't fall straight in. It forms another disk around the white dwarf. As the gas spirals inward, it heats up more and more until it finally crashes onto the surface. And, when it does, it releases huge amounts of energy in the form of X-rays. Here's the key breakthrough. Scientists noticed that the X-ray signals were shifting in a regular pattern. That pattern matched the orbit of the hidden companion. In other words, the X-rays were moving exactly the way they would if they were coming from something orbiting the star. That was the missing piece of the puzzle. After more than half a century, astronomers finally had clear proof. The mystery wasn't caused by magnetic chaos. It was caused by a white dwarf feeding on material from its partner star. This discovery, led by Yael Nazeh, didn't just solve one mystery, it opened the door to many more questions.